My dear students, welcome to our maths class. Here I am your maths teacher Sajini John. In the previous classes, we have learned about expansions. That is, expansion of a plus b the whole square, which is a square plus b square plus 2ab. Then a minus b the whole square, that is a square plus b square minus 2ab. Then sum of these two identities, that is a plus b the whole square plus a minus b the whole square. We know the result is 2 into a square plus b square, and the difference between these two, that is a plus b the whole square minus a minus b the whole square is equal to 4ab. Then some more identities we have learned, that is a plus 1 by a the whole square, a minus 1 by a the whole square, then a plus b the whole cube, a minus b the whole cube, all these things. Okay. Now, and we are using some of these identities for the next chapter. Okay, such as a square minus b square is equal to a plus b into a minus b. A cube plus b cube is equal to a plus b the whole cube minus 3ab into a plus b. Do you remember all these things? And a cube minus b cube. Okay, so you have to remember these identities. Now we are going to learn about factorization. Do you remember what is factorization? Factorize. What is the meaning? Factorize. We can write 20, which is equal to 4 into 5. 4 into 5. And now we can say that 4 is a factor of 20. At the same time, 5 is also a factor of 20. So this 20 can be expressed as the product of two numbers, 4 into 5. So both are factors, 4 and 5 are factors of 20. In this way, consider the polynomials. A polynomial is expressed as the product of two or more expressions. Each of these expressions is called a factor of the polynomial. Here you can see one polynomial. First one example. 3x square minus 15. This can be expressed as the product of these two. Look, 3 into x square minus 5 is same as 3x square minus 15. If we multiply these two, 3 into x square, 3x square. 3 into minus 5, that is minus 15. And consider x square plus 5x plus 6 can be written as x plus 3 into x plus 2. In the previous chapter, we have learned how to expand x plus 3 into x plus 2. That is x square plus 3 plus 2 into x plus 3 into 2. The same. X square plus 3 plus 2 into x, that is 5x, plus 3 into 2, that is 6. So this polynomial can be expressed as the product of two expressions. They are x plus 3 and x plus 2. In this case, we can say that x plus 3 and x plus 2 are the factors of x square plus 5x plus 6. This is what factorization. That means the process of writing an expression in the form of terms or brackets multiplied together is called factorization. Each term and each bracket. Here each term, this is one term, this is another term. Each term and each bracket is called a factor of the expression. And there are some methods of factorization. First we can study type 1. taking out the common factor. The first method is taking out the common factor. For that, we can consider one example. Look here. Factorize. Write this question, factorize. Then 4x square y minus 2xy. Factorize this expression. Here the first method is taking out the common factor outside. Here you can see in these two terms what is common. What is common factor? We know in 4 and 2, 4 can be written as 2 into 2. Therefore, 2 is a common factor. It is very clear. And you can see y is a common factor. And here you can see x square, that is x into x. So, 2x are here, x into x. So, x is also common. So, in total, we can say that 2xy is a common factor in these two expressions. So, we can take 2xy outside from this. Look, when we take 2xy outside, you can write this expression as 2 into x into y minus 2xy. Here 2x and y. Here 2xy. Okay. These things have to take outside. So what is the remaining part in the first term? That is very clear. 2 and x. That is 2 into x. So inside the bracket we can write 2x. Here 2xy can be written as 2xy into 1. Therefore, if we take 2xy outside, the remaining part is 1 only. Therefore, the result is 2xy into 2x minus 1. One more question. Look, second, B. Write this question. 3a into a plus 1 plus 5 into a plus 1. Here what is common factor? A plus 1 is common factor. It is very clear, only a plus 1 is common. So we can take a plus 1 outside. What is the remaining part? Here 3a and here 5. So when we take a plus 1 outside, the remaining is 3a plus 5. So the result is a plus 1 into 3a plus 5. So these two are the two factors. A plus 1 is a factor of this expression. At the same time, 3a plus 5 is also a factor of this expression. So we get two factors. In the first example, how many factors you can see? Look, 2 is a factor of this expression. X is a factor of this expression. Y is a factor of this expression. And one more factor you can see, 2x minus 1 is a factor of this expression. Okay. Now, in exercise 5a, first question. You can write this a long expression. Only two terms you can see. Terms are separated by plus or minus sign. Okay. So you can see one expression here together. This is another expression. I'll read the question. 2 into 2x minus 5y into 3x plus 4y minus 6 into 2x minus 5y into x minus y. First you have to find what is common factor. 2x minus, we can see 2x minus 5y here. Here also 2x minus 5y. Okay, so we get one common factor, 2x minus 5y. This 6 can be written as 2 into 3. 6 is 2 into 3. Here also you can see 1, 2. So, which are the common factors? 2 into 2x minus 5y is a common factor. When we take 2 into 2x minus 5y from this first term, remaining part is 3x plus 4y. When we take 2 into 2x minus 5y from the second term, the remaining is minus 3 into x minus y. So, in this way we can take it outside. Look here. 2 into 2x minus 5y can be taken outside. Inside the bracket, 3x plus 4y minus 3 into in bracket x minus y. Now you can simplify this bracket. Look, 2 into 2x minus 5y into 3x plus 4y minus 3x, then minus 3 into minus y, that is plus 3y. And you can simplify this bracket again. Look, 3x and 3x like terms. Therefore, they are cancelled. And 4x plus 3y, that is 7y. So, at last we can write 2 into 2x minus 5y into 7y. That is 2 into 7y, that is 14y into 2x minus 5y. You can write one more question here. Write this question. 2x into a minus b plus 3y into 5a minus 5b plus 4z into 2b minus 2a. Here, what is common factor? You can see one a minus b here. In the second term, 5a minus 5b. If we take 5 outside, we get 1a minus b here. Okay? And the last term, 2b minus 2a. If you take minus 2 outside, the bracket becomes, here it becomes minus b, here becomes plus a, that is a minus b. Okay, in that way you have to arrange. So, 2 into x into a minus b, that is the first term. Second term, we can take 5 outside, so we get 3y into 5 into a minus b. Here 4z into, you can take minus 2 outside, it becomes minus b plus a, that is a minus b. So the next step we can write 2x into a minus b plus 3 into 5, 15y into a minus b minus 4 into 2. This minus is here. Okay, 4 into 2, 8. 8z into a minus b. Arrange it like this, a minus b. Now it is very clear a minus b is common factor. So you can take that a minus b outside, and inside the remaining part you can see it is very clear, 2x plus 15y minus 8z. So these two are the two factors. You will get two factors here in this expression. A minus b is one factor, other one 2x plus 15y minus 8z. Next type is grouping method. Type 2, grouping method. We can consider one question. Factorize a cube plus a minus 3a square minus 3. Here you can see 4 terms. You can see 1, 2, 3 and 4. The terms are separated by plus or minus sign. So 4 terms are there. What is grouping method? This expression of an even number of terms. Here 4 terms are there. So an expression of an even number of terms may be resolved into factors if the terms are arranged in groups such that each group has a common factor. That is, group the terms of the given expression in such a way that each group has a common factor. Here we can consider the first two terms is the first group and last two terms we can consider as second group. We can see in the first group there is a common factor. What is that common factor? Now two groups are there, 1 and 2. Then factorize each group. That is the second step. Factorize each group. You can see here one common factor A. A is common. When we take that A outside, we get A into, the remaining is A square plus 1. Here also you can take minus 3 outside. Becomes A square plus 1. Now we factorized two groups. Now from each group obtained in here, take out the common factor. Now we can see one more common factor in these two terms. What is that common factor? A square plus 1 is a common factor. We can take that A square plus 1. It is very clear, A square plus 1 is a common factor. If we take A square plus 1, what is the remaining? A minus 3. This is what? Grouping. Now one more question. 16 into A plus B the whole square minus 4A minus 4B. Here we can see only 3 terms. Anyway, here when we see this question, we can understand that here in these two terms, if we consider these two last two terms, if we take minus 4 outside, the remaining will be minus 4 into A plus B. Okay, you can see 16 into A plus B the whole square minus 4 into A plus B. Now 16 can be written as 4 into 4. So we can see 1 4 is a common factor. At the same time A plus B also a common factor. Okay, this is very clear. A plus B is a common factor. At the same time 1 4. From here and from here we can take 1 4 outside. So 4 into A plus B, then inside there is, the remaining part is here, 4 into A plus B minus 1. 4A plus B we are taking outside. Okay, so the result is 4 into A plus B into 4A plus 4B minus 1. Now you can see one more question. A square plus 1 by A square minus 2 minus 3A plus 3 by A. This is the question. Here we can see 5 terms are there. 1, 2, 3, 4, 5. First you have to identify what is A square plus 1 by A square minus 2. In the previous chapter we have learned A square plus 1 by A square minus 2 can be written as A minus 1 by A the whole square. Now these two, from these two we can take minus 3 outside. Then the remaining is A minus 1 by A. Now it is very clear that A minus 1 by A is common. Or we can write A minus 1 by A the whole square is A minus 1 by A into A minus 1 by A, then minus 3 into A minus 1 by A. We can take one A minus 1 by A outside. The remaining is A minus 1 by A minus 3. We are taking A minus 1 by A outside from both terms. Okay, so these two are the two factors of the given expression. Now we can see one more question. Look, a square plus 4b square minus 3a plus 6b minus 4ab. Here, when you see this question, you have to identify a square plus 4b square minus 4ab is a perfect square. Okay, so rearrange these terms like this. A square plus 4b square minus 4ab together. And the remaining minus 3a plus 6b. Now, this is in the form a minus b the whole square. Here instead of b square, here 2b the whole square, that is 4b square. So, it is very clear that this three expressions can be written as a minus 2b the whole square. A minus 2b the whole square. If we take minus 3 outside, we get the result here also a minus 2b. Look here, a minus 2b the whole square is, when we use a minus b the whole square, that identity, we will get this result. Now take a minus 2b outside, we get the answer a minus 2b. One a minus 2b is remaining here. A minus 2b into a minus 2b minus 3. So in the first exercise, question number 2 and 3, then question number 2, 3, 7, 9, 10, then 14, 19 and 20 homeworks. So in this chapter, in factorization, once again you have to remember what is factorization. Factorization means to express the given expression as the product of, here you can see product of two more expressions. And we have learned two methods, that is factorization by taking out the common factors outside, then factorization by grouping method. So do all these questions once again and let me conclude. Okay, thank you.